Hello, today we're going to solve this problem where we want to find the diameter or the maximum diameter of a binary tree. Now what this problem says is that you're given the root of a binary tree just like any other tree problem, and you want to return the diameter of the tree. Now diameter has a specific definition. What it says is the diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. That's an additional information you have. So I'm going to take up an example from Leetcode, which is something like this. 1, 2. I like this example a little more because it explains what the problem is. 1, 2, 3, 4, and 5. Okay, and now you want to find out what the diameter of this tree is. Okay, so you want to find the longest path. All right, the length of the longest path between any two nodes. Now let's have a look at what this longest path could be. So if you go from 5 to 1, how many nodes you gotta cover? 1, 2, 3. Okay, if you go from 5 to 4, 1, 2, 3. If you go from 2 to 1, then you gotta just cover one node. All right, if you go from 3 to 4, you gotta cover two nodes. If you gotta go from 3 to 1, you gotta cover two nodes, and so on and so forth. So the longest path is you go from 5 to 4 or 5 to 1 or any one of these, right? So it's the longest path is going to be 3. Okay, let's say if we had another number over here which was 9. I know it's not a binary tree anymore, but let's just for the sake of it, it's not a binary search tree anymore, but let's just for the sake of it have something over here. Okay, if you want to go from 9 to 5 or 5 to 9, how many nodes you got to cover? 1, 2, 3, 4, right? If you want to go from 9 to 4, then 1, 2, 3. Okay, if you had this, then your output would have been 4 because the longest path is 5 to 9, right? And we want to basically solve this problem. Now let's erase this guy for 1 second. Let's just solve this problem first. Let's understand what's really happening. Well, at this, we want to do is when we want to find a diameter, we want to, let's say, find the diameter at every possible node, right? So what I mean by diameter is we're going to explore what is on the left, how many nodes are on the left and how many nodes are on the right, and then we could just add it because that's going to give us a diameter at the specific node. For example, if it's 5, then we have nothing here and we have nothing here, so the diameter over here is going to be 0 because it has nothing. But if you look at 3, it has one node, all right? So it has one node over here, and it has no nodes over here, so the diameter is going to be 1 here. Okay, so basically, if I get the height of whatever I have on the left, and if I get the height on whatever I have on the right of a specific node, okay, and then if I then add them, then I will find the diameter at that specific node, at that specific level, or at the specific node. And if it is the highest diameter I've come across so far, then I'm going to update a variable which stores the largest possible diameter I have so far. Okay, so let's start with that. So if I have a variable called d, which is initialized to 0, then at 5 I have nothing, so this has no nodes on its left and its right, so the height of its left child and its right child is going to be 0, so the diameter at this specific node is 0. All right, okay, so this does not get updated because it's already 0, but this node is going to return not the diameter at this level, it's going to return its height, right? Okay, because for this we need to know the height of for what it's on its left. So 5 is going to return 1 because its height is 1, it's at level 1. And then 3 is going to look at its right, it has nothing, but it has one child on its left, which is the height of 1. So it's going to do 1 plus 0, which is going to be the diameter of 1, and which is already greater than whatever we have so far. So we're going to update the diameter, and then we're going to return to its parent the height of 3, which is what? Whatever it got from its left and whatever it got from its right, the maximum of that plus 1, right? We already solved the height problem. So this is going to return 2 to this node. So we have a height of 2 from the left of 2, from the node 2, and a height of 1 is going to return 1 because it's the same as this, right? From the right of it. So the diameter is going to now be 2 plus 1, which is going to be what? 3. And then 2 is going to return what? 2 is going to return the maximum of this plus 1, right? Because it's going to return its own height, right? Which is going to be 2 plus 1, which is going to be 3. So 1 has 3 coming down from its right, and it's going to have no child. It doesn't have any child on its left, so it's going to get 0. So the diameter is now going to be 3 plus 0, which is again 3. Great. Right? And then it's going to return, whoever called this guy is going to return 3 plus 1. It's its height, right? But we don't want to return whatever this guy returned. Its height is going to be 4. We don't want to return the height of 1. We want to return this variable. And by, iterating through all of this, we get a height of what? We get a height of 4, but we're not going to return 4. We're going to return 3. Now let's say if we got 9 over here, then this guy would have returned a 1, right? And the diameter would become what? 3 plus 1, 4, and we would have updated this. But the height that 1 would return would still be what? The maximum of this 2 plus 1, right? So it's going to be 4, right? So that's how we're going to solve the problem. We're going to break this problem into two. We're going to, or not, let's not say break, we're going to reuse whatever we did to find the height of the binary tree, which is a problem we solved earlier, and use that and build upon the solution for this. Okay, now let's have a look at the code. Okay, to start off, we're going to declare that d variable that we talked earlier. So I'm going to make it a list because the way that I usually solve this problem is I'm going to have a function, and if I want to access a list through a function, it's a lot easier, right? And we're going to reuse. So the idea is that we're going to get the height, right, of each child, and then we're going to calculate the diameter. If the diameter is greater than what the current value d is holding, if it is greater than that, we're going to update whatever d is holding. If not, we're going to keep the diameter as it is. All right, so we're going to have a function which is going to be height, and the way this function is going to be constructed, that it's going to return me with the height at a specific level, right? And we've done this before. So it's going to take in a node, and then we're going to do one check, which is first we're going to check if the node is null, or if it's not there, then I'm going to return a 0. And then I'm going to call, I need to find the height of the left child, I need to find the height of the right child, right? And then that's going to be the diameter at that specific node. So if I know what the height of this child is, which is 1, 2, and if I know what the height of this child is, which is 1, then I'm going to just add them to get the diameter. So I need to call the height function, because this is the way it's going to be constructed. It's going to return me the height. It's not there yet, but it's going to work. So I call it on the left child, I call it on the right child, and then I need to find out the diameter, right? So the diameter is just basically left plus right, and if the diameter is greater than d, then I update. If it's not, then I keep d as it is. So d of 0 is going to be max of whatever d of 0 is currently now, and whatever we found for diameter. Okay, so that thing's done, and this function is just gonna return me with the diameter, right? So I'm going to return, the function is going to return me with the height. So I'm going to return the height at that specific level, which is going to be what? The max of this 2 plus 1. So it's going to be max of left and right plus 1. And then I'm gonna call in this height function on the root node, but that process is eventually gonna have the diameter be stored. I mean, the d0 value is gonna store the largest diameter, right? But this function is going to return you with the height, which I don't want. So I'm going to return d of 0. Okay, I think we made a little mistake. Oh. Great.